All right, we're back at the ramp. A couple things have changed. First of all, the disks are identical now, but the forces are different. Disk A is going to get 2F. Disk B is going to get regular F, but the times are the same. Okay, the forces again are removed before the disks reach the curved section. So it might be worth noting MA equals MB, FA equals 2FB, just so that we don't lose that when we start thinking about what's going on. Now, this is similar to the graph before, but now we've got momentum versus time. Well, if the disks have the same mass, then this is really the same shape as the velocity versus time graph before. If the disks were different, we would have to account for that, but we don't, so let's not make this more difficult. The graph shows momentum of each disk. Identify which disk's motion is represented by this solid line. Okay, well, the solid line is going to have more acceleration, okay, because essentially this is a velocity versus time graph. So who's going to have the greater acceleration? Well, it's going to be the disk with the greater force attached. So the answer is disk A. So there's two ways to get these 3 points. There's one way that I just did it by saying that relating momentum to speed or velocity. So saying 1 point for disk A, 1 point for relating momentum to velocity, which is what I did. I said the momentum graph is basically the velocity graph since the masses are the same. And then 1 for saying that disk A has a larger acceleration because it's related to the slope. However, you could also go another way and realize that F delta T is equal to delta P. Well, what we have here is a graph of delta P versus delta T. And so if we did that, we could say, since we have a graph of delta P versus delta T, we could say, oh, the force is the slope of that graph. Right? Now, honestly, I wouldn't have thought of this probably in a million years, but it's accurate and it's true. And so you could say, well, the bigger slope is the solid line. That means it's a bigger force. That means it's disk A. So either way there, you get 3 points. You get 1 point for identifying disk A. You get 1 point for relating the slope of that line to either acceleration or force. And then 1 point for realizing that disk A has either the larger force or the larger acceleration, whichever way you went. So 3 points there for part A. Right? Part B, during the time interval that the forces are exerted on the disk, which disk, if either, travels a greater distance along the horizontal section? If they travel the same distance, say so. All right, so since disk A experiences a larger force, therefore a larger acceleration, it's going to go farther. So you get 1 point for disk A and a justification, and I thought the justification took more time than 1 point. But anyways, we know that the force on A is greater. And so we know the acceleration of disk A is greater. And so then by this kinematic formula here, delta x equals v initial t times 1/2 at squared. Okay, both initial velocities are 0 since disk A has the larger acceleration and the times are the same. Disk A should go the greater distance. So again, 1 point for disk A and then justifying why it's disk A. Part C is going to ask who reaches a greater maximum height, okay, after they travel up the curved path. And the answer here is disk A again, okay, disk A again. And I think that C is just the answer, and then D is our justification, okay. After the forces are applied, disk A is going to be going faster and have more kinetic energy. So you can justify that a few ways. You can say that the impulse for A is larger, okay, because J equals F delta T, and A has a larger force for the same amount of time, which means that P of A is going to be larger than P of B. Since they both have the same mass, V of A is going to be larger than V of B, and therefore K of A is going to be larger than K of B. Then using conservation of energy and saying that the kinetic energy, this is for both, the kinetic energy at the bottom equals the gravitational potential energy at the top. The item with the larger kinetic energy is going to have a larger gravitational potential energy. Since gravitational potential energy is equal to mgh, the larger gravitational potential energy is going to go to a higher height. In all of those situations, it's disk A. Disk A has a larger velocity, disk A has a larger kinetic energy, disk A will have a larger gravitational potential energy, and therefore a larger height. So 1 point for part C, just for saying disk A, and then we have 1, 2, 3, 4, 5 points for our explanation. 1 for relating kinetic energy to speed. 1 point for shoving conservation of energy in there somewhere. 1 point for saying a greater kinetic energy at the bottom will be a greater gravitational potential energy at the top. 1 point for saying that greater gravitational potential energy means a higher height. And then 1 point for a paragraph. So hopefully that was pretty similar to question 3 and maybe a little bit easier.